Thanks again, John, and thank you, Jessica. So it's my privilege to welcome our first keynote speaker, Professor Carl Gombrich, the academic lead for the London Interdisciplinary School. Professor Gombrich is a British interdisciplinary educator, academic, and opera singer. I didn't know that earlier, and co-founder of the London Interdisciplinary School. He received a master's degree in theoretical and mathematical physics from King's College London, as well as a master's degree in philosophy from the University of London. Carl was the Royal Opera House Scholar at the National Opera Studio, where he sang bass. He has performed in various operatic roles such as Mazzetto in Don Giovanni with the Garsington Opera, and as Macduff in Ernest Bloch's Macbeth at the University College Opera. Carl was a professional teaching fellow of interdisciplinary education at UCL and founding program director of the UCL Bachelor of Arts and Sciences degree, one of the first liberal arts degrees to be offered in UK. In 2019, he moved as a founder to the London Interdisciplinary School, which has recently been granted full degree awarding powers, the first new institution to receive this in the UK since the 1960s. That's terrific, really. It will admit its first cohort in 2021 with an interdisciplinary curriculum focused on the study of complex problems rather than of specific subjects or disciplines. It has already partnered with companies such as Virgin, the Metropolitan Police, Jacobs, and McKinsey, which will offer students paid placements at London Living Wage. Carl is a regular speaker at events on interdisciplinarity and liberal arts and sciences, and is well known for his writing on the philosophy of education and interdisciplinarity, as well as music. In interviews, he references his pastimes as singing, reading, and watching Arsenal. I now request Professor Gombrich to deliver the keynote address.
Thank you very much, Babia. I think a lot of that, which is interesting for the theme of today, a lot of your introduction might have been from a Wikipedia page, which was recently set up for me by an ex-student of mine, somewhat to my horror, really. And she said she did struggle to get me through the notability criteria of Wikipedia, but managed to convince them somehow because of my past as an opera singer, which did tickle me. And I don't usually reference that so heavily in my work these days. I haven't been a singer for 20 years, but it was interesting in terms of the sort of knowledge revolution and what we're going through now, that this is now my public persona, the Wikipedia page, kindly put together by my student from UCL. So I'm going to give a talk. I hope it won't go over 40 minutes. I'll try to keep more like 35 minutes on interdisciplinarity, why now? And when John asked me to speak at this conference, firstly, I was rather terrified because I have enormous respect for engineers. And so I tried to get out of it. And I said, John, I haven't had that much to do with engineering for a good 2 years now. I've been setting up this new university, which has been very bureaucratic, and it's a totally kind of interdisciplinary education. It's not that much focused on education. And John said, don't worry. Tell us about something that you know about just interdisciplinarity, and we'll kind of take it from there. So I thought, okay, that sounds great. So that's something I can kind of riff off. So the talk will be very broadly about interdisciplinarity, things that we know and talk about in the knowledge revolution, and the sort of implications for curriculum that I think come out of that. But I will also weave in some of the very important experiences I had with engineering on the liberal arts and sciences program I set up at UCL, which I hope may be of more direct relevance to people in the room. Now, I'm still learning an awful lot about this, and there are many people on this call from whom I'm learning a great deal indeed. So I hope we can enter all this in the spirit of learning and sharing knowledge in this extraordinary point in history. So as John mentioned, and Babia mentioned, I was at UCL for nearly 20 years, but the last more or less 10 years of which were incredibly exciting for me. I'd had an interesting past. I'd studied maths and physics and philosophy and music. I'd been very interested in literature and languages as part of my musical education. But I hadn't done a PhD, partly because I went off to be a musician at the time. And when this opportunity to launch the biggest and most radical interdisciplinary degree in the UK came up, it was an incredible opportunity for me and something I never really imagined doing even 15 years ago. And it was this opportunity to bring so much together in my life and make sense of it in an interdisciplinary context. So it was kind of action research, which is otherwise known as kind of doing it and tinkering and making it better as you go along. And then UCL were kind enough to make me a professorial teaching fellow of interdisciplinary education in 2018 as a result of that, the impact of that degree. So I guess now I'm a philosopher of education, though I do sometimes kind of wonder what that is. It's slightly parasitic on what other people are doing, but it's a fantastic vocation actually, and fantastic opportunity to talk about so many different things going on in the world of education today and put them into practice, as I did at UCL. And now I jumped out, as John mentioned, 18 months ago to found a brand new university built entirely on interdisciplinary lines. So one thing we're doing, and I'll return to this in some detail when we talk about our curriculum at LIS, is think about problem-based learning, in which I know engineers know a lot about. As I say, I'm learning from you on that, but in a completely interdisciplinary context and how that might look in a curriculum of a new university, which won't have any departments. So going back to setting up the BASC in 2010, it was very important to me to kind of try to recapture some of the historic benefits and aspirations of liberal arts and sciences to be kind of universal. And UCL having this extraordinary kind of breadth of brilliance across all the faculties, I really wanted to include engineering. But that's very rarely done in liberal arts and sciences courses. So it was kind of a revelation to me to come across Dave Goldberg's work in the early 2010s. There was a series of 3 little videos on YouTube. I think he must have made in about 2010. And I stumbled on them maybe a year or 2 later. And he presented engineering as basically this human-centered thing, that engineering was sort of at the service of humanity. And that led me to look at what Olin was doing, Rick Miller, and so on. But I was really struck by that way of phrasing it, because that's really what the liberal arts and sciences kind of claim to be doing, to be understanding humanity, interpreting it, and in some way making the world a better place. They have a particular emphasis on citizenship and so on. But Dave Goldberg's pitch, if you like, that engineering had to recapture its human-centeredness, made a tremendous impression on me. And so we worked to include many engineering modules in the arts and sciences degree at UCL. And I will be ever grateful to John, who's on this call, wonderful colleagues, Mark Midovnik, Sarah Bell, Manuel Tilley, and many others for being so generous in thinking how our students, who typically came from very broad backgrounds with some science or maths qualifications at A-level, but a lot of arts and humanities and social sciences background, how they could engage with engineering. And when you had, a course like Sarah Bell, who took all the students off to measure on the bowels of UCL to look at the toilet usage of water and then metering this water and coming up with various proposals, which they then put out in a genuine tender process to UCL estates management to discuss how to increase water efficiency. I mean, this is still seems to be these first-year students who have no experience of engineering, incredibly creative and life-changing experience, I think, for these arts and sciences students. Mark Midovnik and Emmanuel's wonderful courses redesigning shoes and helmets and all sorts of wonderful design engineering projects and courses which our students took. So we had a small but very dedicated and interested part of the arts and sciences program, which was devoted to engineering. And by the time I left, well over 100, 120, 140 students had taken some of these engineering modules on our liberal arts and sciences course. And many of them have actually gone on to do engineering at masters and PhD. I do lean on this first example quite a lot. It's an N=1, of course, but it shows just what is possible in attracting students to engineering via different routes, I think. Particularly interesting was on the gender issue, because of course, being a liberal arts and sciences course, we had almost 2/3 were female, also on our engineering modules. And it was interesting to note how engaged women were in engineering. That's by this route. They wouldn't have met engineering other than come by this route. And so Lena is an interesting example of that. She's now at Oxford doing a PhD in civil engineering. And while on our course, she studied engineering modules, but also kind of environmental economics, environmental law. And in fact, in her second year, she wrote a report on the use of sporting infrastructures after they'd been used in big events like the Olympics and the World Cup and so on. So she was kind of toggling around the environment and then gradually got interested in engineering the environment and did her undergraduate dissertation on anaerobic energy production, small scale kind of circular economy things. So she's now on a very prestigious PhD program at Oxford. And she just won, and this is a nice slide for me to show you, on November the 3rd, a major international prize for her research from the Allianz Foundation. And they said that they loved her work because it was particularly interdisciplinary and assessed across a nation's entire built and natural assets, their energy, provision, healthcare, and ecosystems. And particularly Lena's thing, which I should have mentioned, Lena's thing is looking at the climate change resilience to flooding of small island states. So she looks at when states come under threat of flooding due to climate change and looks at their resilience. So she's taught herself proper modeling along this educational journey, GIS modeling, but she also looks at things from anthropological perspectives, political science perspectives, economics perspectives, and so on. And so she has this unique combination of interdisciplinary skills which make her an interdisciplinary expert engineer. And this is something I'm going to return to a lot throughout this talk. She puts together different ways of viewing the project, one of which is engineering and a part of which is technical, but she's really an expert in her thing because of her interdisciplinarity, not in spite of it. That's a phrase, if anything, I'd like you to take home. She can only be this type of expert in her particular thing because it's so interdisciplinary, not in spite of it. So she's not doing a little bit of this and a little bit of that. She's doing a highly focused niche engineering project, but it also brings in other disciplines. So it needs to spend some time on that. She doesn't do as much civil engineering and modeling as some of her colleagues, but she does enough to be a genuine engineer, combining it with other things. So a little bit more in the history, because I am a philosopher and historian of education. And it's interesting, I think, to think how these things are coming together in some ways and where they come from. Engineering historically has been associated with manual labor. It's what's called a practical art in the more historic literature. And so it wasn't regarded as a true liberal art, which was, liberal arts was regarded as the education for someone who didn't need to work, you know, that aristocratic idea, which was a reality, of course, for many wealthy elite. Not nearly as many as the non-wealthy elite, but still the rulers of those societies didn't have to work. They had other incomes, and the education of liberal arts was supposed to, as I mentioned, sort of make them great citizens and contribute to society, but in that sort of a way. And that idea goes back to Cicero, the great Roman orator. However, there is a smaller tradition within that, starting with Cicero's older predecessor, Varro, that thought we should include practical arts like architecture in the liberal arts. And there was a monk much later, but still a long time ago, Hugh St. Victor in the 12th century, who made a plea to include what he called more of the mechanical arts into the liberal tradition. And I think this is interesting because I think we might see another turn of the wheel here. You know, we had this quote from Mort Friedman, many of you will be aware of it, from Columbia Engineering in the thousands, that engineering is the newest liberal art. That's a bold thing to say. What was he getting at? What did he mean by that? And I think he meant this kind of human-focused aspect of engineering, that engineering should return to that if it's moved away from it, be at the service of humanity, the service of society. But it was also, I think, perhaps in the best possible way, a little cheeky dig at what had happened to some of the humanities and social sciences in moving away from that and becoming a bit too insular and a bit too inward looking. So you have these waves in history. I mean, the Renaissance is one we'll all be familiar with, when people really did seem able to grab different parts of the knowledge world, let's call it loosely, and put them together to invent worthwhile and practical and useful and exciting things. And engineering has a chance, again, and perhaps more than a chance, perhaps it's needed. The engineering mentality is, again, needed to do this now that we're moving into this new era of extraordinary possibilities of combination. So I think that's perhaps how we might see these things as relating to each other. You have this broad tradition of liberal arts and sciences, which has been largely thought to be detached from practical manual things, but you have the engineering tradition of kind of making and of service and of use. And now you see that both of these things are combining in some way under this larger umbrella of interdisciplinarity, and how we might combine various subjects and subject areas to produce things of value to the world. Many of you will be very familiar with this term interdisciplinarity, but I find that its recognition is incredibly complex, context dependent. I gave a talk at a big school event last Monday, and many students have never heard of this word, school students, particularly in this country. So when you ask what interdisciplinarity means, you get answers like, is it to do with being punished? Or is it to do with being let off your punishment? And you have to begin this big story about, no, it's about combining disciplines in new and interesting and more worthwhile ways. So I thought it would be worthwhile in this talk just to have this fairly common definition of interdisciplinarity, that it's study or research which combines the methods and knowledge of two or more existing disciplines in order to create a synthesis which would not have been possible using only one of the disciplines. More expanded definitions will say things like a synthesis, which could be a product or a report or an argument or a policy. You can fill that in there, but the important thing, I think, and I mentioned it a little bit with Lena, is the PhD student, is combining things in some way to create a whole which is greater than the sum of the parts. And this is interesting, I think, philosophically, because it is distinct in a way from analysis, which is the breaking down of something, if you like, in a reductionist way, to understand it more and more in terms of its parts. And I think it's very interesting in education to think how we can start to value synthesis, which is inherently sometimes very creative, and reward students for that approach rather than valuing analysis. I think we're good at valuing analysis. We know what it looks like. We know how to give it a big tick. We're not so good at evaluating synthesis. And an anecdote I like to tell here about a friend of mine called Kate Rayworth, who's an economist who wrote a book a few years ago now called Donut Economics, which is having an impact on the way we think about economics and indeed wider policy impacts. And she's a product of an elite education system, first-class degree, Balliol, distinction and masters and so on. Interestingly, though, she chose not to do a PhD because she felt that would narrow her too much. And she was at an event once where someone was talking to her and they said, oh, well, you're clearly one of these high achievers. And she thought for a moment, she said, actually, I'm more of a wide achiever. And so she was very great for me to talk to setting up the Arts and Sciences BASC, because her whole kind of take on how you would create a more interesting economics was to draw on different disciplines, different disciplinary perspectives, have more synthetic input, if you like, into the discipline of economics in order to regenerate it, to create something new. But going narrower and narrower, more of the same economics, you were never going to get a new product. So with Kate, I've batted this around a bit. You know, we want to make a case that synthesis is hard. Synthesis is worthwhile. You'll have to spend some time doing synthesis, which is different to doing more and more analysis. And that is a slight mental shift in how we educate. So on to interdisciplinarity, why now, a little bit more. This is a phrase, it's one of these things, you know, I made up this phrase and then I thought, no, I can't have made that up. It sounds like somebody else would have made that up. So I Googled it in quotes and I've never been able to find it anywhere. So I think I did make it up. And I want to make the point, which you all know, but it still bears repeated saying, that we're living in this extraordinary time where there's an explosion in the combinatorial space of ideas around us, literally around us. You know, we have these electromagnetic waves carrying this information with the thoughts, billions and billions of thoughts from millions of people all around us. And we could, if we had the kind of sensory equipment, we could literally pluck these ideas out of the air and combine them, sometimes meaningfully, most often not meaningfully. But the potential for kind of recombination is just unimaginable compared to, say, 30, 40 years ago. Of course, a lot of it's dross, but that doesn't matter. The potential for not being dross is just immense. And we know this is how innovation works very, very often. So Stephen Berlin Johnson, the guy who writes about ideas, talks about combining things that existed before, but in new ways to make new things. And the example he gives is of the printing press, which used to be a wine press. You know, you'd screw something down, it would squish the grapes. And Gutenberg thought, if I put some blocks on there with some ink on them and screw it down on some paper, I'm gonna have something to look at. And so combining some ideas of typeface and wine presses, you come up with the printing press. And so there are many examples of this that Berlin Johnson gives, and other surprising results that come out of this connectivity we have in the space of ideas. Some of you may be familiar with the Lakhani work, I think, from the Harvard School of Education, from looking at incentive. He found that often the best people for solving problems were not near experts to the problem because they had kind of too much experience of the problem. They were too narrowly fixated, but people coming in from very different disciplines with enough technical understanding to understand what was going on, but completely different perspectives on the problem. That feeds into the whole debate about expertise. I'm not going to go there now. I think we do need experts, but economics is a good example, perhaps, of where the whole discipline could do with a bit of shaking up from different sorts of experts, shall we say, or interdisciplinary experts. So we live in this explosion of combinatorial space of ideas, transgressing all these boundaries, seeing no gaps really between areas of knowledge, hierarchies of knowledge, and so on. And I think this is one of the things leading to the kind of need for interdisciplinarity now, which I sort of summarize in this more simple slide, that we have these complex real world problems, climate change, sustainability, migration, public health, and they just cross all these different boundaries and require knowledge, information, and methods plucked from all these different domains. But also, people just don't learn in a linear fashion now. As David Weinberger, the internet historian, said 8-9 years ago now, the idea that a book ends with a full stop and that's any kind of meaningful conclusion seems very weird now. There's just, wherever you are, you're just at one point in the argument, and learners feel this. All the students I speak to. So I heard this podcast, which was kind of a combination of AI and politics, and I didn't know what subject it was, and they've been taught that the world's divided up into subjects, that academic disciplines are kind of reified, as we say, they're real things, and you have to do one of them to be really serious. And yet their own learning is completely crossing all these boundaries, transgressing what some might think as kind of canons of disciplines. So there's, if you like, a kind of demand side here, which is the complex problem that demands interdisciplinarity to solve these problems, and a supply side that interested learners are just not seeing the old categories of knowledge, which we built up roughly from 1600 to 2000. And yet still in universities and education institutions, we are really, really struggling to know how to reflect both these things. It's a huge challenge. Any kind of recategorization is a huge challenge. But this very fluidity and this combinatorial environment we live in requires us to try to find new categorizations. And it's a fascinating and difficult problem, and one we need to take on. We can't retrench here, I think. That is defeat. We have to take on this fluidity in the modern world, this interconnectivity, and find some structures which work for us going forward. So just to recap some of the more complex real-world problems, you're very familiar with all these. This is a slide I do show to school students sometimes and say, kind of, what disciplines would you need? Well, climate change, do we start with human behavior or do we start with physics and chemistry? I'm genuinely not sure. I'll come back to the ideas of foundations of knowledge later on. Free speech used to seem to be about politics and maybe law. Now it's maybe as much about algorithms as anything else, and so on. So tremendous opportunities to rethink creative education given these kinds of challenges. So I will come back to engineering's role in this as promised in a few slides. I mean, thinking about these is interesting. Is there any one of these which engineering wouldn't be involved with? I mean, you could say money and currency is the domain of economics, but in fact, economists are pretty bad at talking about money and currency. It doesn't come till, I seem to be having a lot of go at economics, excuse me. They're big enough, they can take it. There's not much on money until you get to the banking system and back end of year 2 usually, and often some would argue they don't really understand it very well, hence the economic collapses we see. Is money about trust in society? Is it therefore an anthropological or psychological thing? So does engineering have a say in that? Well, along comes Bitcoin, and perhaps we're back to some combination of engineering and other human-related things. So I'm going to come back to the notion of what the kind of almost a colonizing potential of engineering into this interdisciplinary world later on. But before I come back to that, I just want to mention our curriculum at London Interdisciplinary School. Sometimes spend 5 minutes on this because it's radical, and I guess it's going to be exciting, and you'll see how it goes. The overall conception is very simple. We have 40% of the time the students spend on problems, and 60% of the time, excuse me, on methods. And those methods are divided 50-50 into qualitative methods, so ethnography, essay writing, arts practice, and quantitative methods, so data science, mathematics, scientific experimental, and so on. And we will look at broad problem areas, 1 per term, and there are the problem areas listed. Public health, social issues, could be anything from knife crime to education, and so on. And we'll work with the students to refine a problem statement in each of those areas each term. And we will then provide them with, I think, a tremendously exciting, very broad, very ambitious, but certainly the first year we'll provide them introductions to many, many methods, ways of doing things, ways of researching, ways of investigating. And then as they go through the degree, they can specialize more in some methods, but we will always insist that they keep some kind of balance of this qual and quant separation. Now I'm going to go to a web page here, and I really hope this is going to work because of all our sharing issues. Can you see that?
Yes.
Great. This is quite exciting. So I'm going to zoom out a little bit. So you can see there we've got problems down the middle. That's 40% of our curriculum. Methods, 30% quantitative, 30% qualitative. And we have a little legend down here, which I will zoom into. So I'll close your eyes and you can see what these bubbles mean. So there you go, quantitative methods, qualitative, problems 1A, that's the first problem, the second problem. Now threshold concepts I'm going to talk about a little bit more, and ways of doing is basically kind of details on the methods. So how it's meant to work is that students will study happiness. In particular, we have refined a problem statement, which will be how can we measure unhappiness? And then that becomes the locus of all the learning for 5 weeks in this case, 10 weeks in some other cases. And in the problems part of the syllabus here, where this is, I think, in a way, the most ambitious thing. Hello, can you hear me? Yeah. We're going to do disciplinary deep dives, 2 weekly deep dives into a discipline and think about how that discipline would consider that problem statement. And we're going to use the idea of threshold concepts, which many on this call will be familiar with. They were kind of researched and named by Ray Land and Eric Meyer in the thousands, and still the best page on threshold concepts is hosted, I think, by UCL's engineering, electrical engineering. So you can look them up there. And the idea is that there are these big, interesting concepts which are kind of gateways to disciplines that once mastered, you sort of have an insider view of how a discipline works. They are very challenging. They're sometimes called troublesome because they force you to see the world a different way. They're also transformative for the same reason. In some ways, they're integrative within the discipline. They help you put things together. And there's been a lot of research on this. There's a big literature around threshold concepts now, but to my knowledge, they've never really been rolled out very systematically. And perhaps we'll see why in a couple of slides. But we want to try this. We think this is an exciting way to introduce students to philosophy or neuroscience, whatever discipline it might be. And we're going to choose a threshold concept which allows you to enter the discipline on the one hand, but also think about this problem statement, how might we measure unhappiness? So let's take an example from linguistics. You might talk about happiness in terms of valence, whether it's good or bad, or strength of arousal. So that allows you to talk about valence in linguistics, bring out ideas of metaphor and so on, but it also quite directly a light can be shone on how we're thinking about the problem statement. How do we measure unhappiness? What do people mean by the word measure and unhappiness and so on? And how is this being recorded? So that can actually bring in a whole big data piece now about sentiment analysis and so on. So we've identified a bunch of threshold concepts we think can do this joint job. They introduce you to the discipline, and then you use that also to shine a light on the problem statement. And then alongside that, we teach various methods, as I say, that divide along qualitative and quantitative, and we use the vehicle of the problem statement to introduce the method. So if we look at the quantitative methods here, we have introduction to scientific methods is going to be an experiment where students in a class are going to provide some data on their own feelings about happiness, some kind of questionnaire, recording their happiness, and we'll introduce them to the scientific method through that process. Conversely, in qualitative methods, we might have ethnography and self-ethnography. So there may be some journaling, some recording of emotions of oneself or one's community, a kind of anthropological approach to happiness, which again uses the problem statement, how can we measure unhappiness, as a vehicle for teaching a methodology which is transferable. That's the point about the methods. They will come to be transferable to many of these different complex real-world problems. So the problem statement is really important. It's the kind of locus for everything, and it gives us a kind of rigorous, clear locus, but it also allows us to do some more traditional things, some high concept stuff, which are related to academic disciplines, and also to allow us to provide tools to students as part of a methodological training. Right, now I want to go away. So let me see if this is going to work. Thank you. So that's our curriculum. So in this, as I say, there are many people on this call much more expert than me in problem-based learning. But I guess the difference here is we're going to try this kind of maximally interdisciplinary approach, pan-disciplinary approach, certainly in the first year. So it's problem-based learning, then involving all the disciplines in some tackling of these problem statements. So I think this is a very interesting question for engineering. I touched on it before. How far can sort of the idea of engineering encroach into this? I mean, I would be a fan. I would somewhat support this because I think engineers generally do a great job, particularly in England. They're underappreciated, understood, I think. I mean, if engineering is going to be human-centered and society-centered, the question does arise, what is not engineering? And if it's not engineering in those senses, is it even worth doing? So that's an interesting conceptual question, I think, for us to think about. One thing we've done at LIS is we have been tried to be modest in some senses. Obviously, we're extremely ambitious in other ways, but we've tried to say we're going to tackle problems rather than solve them. And I'm not sure what engineers would feel about that. But we think particularly these are wicked problems, which, as you know, kind of almost definitionally don't have solutions. You can hope not to make things worse, perhaps, prod the system in one place so that the overall system is a little bit better. But perhaps we need to talk about tackling problems rather than solving them. And in the social sphere, of course, politics in particular, it's always about the least bad solution rather than a particularly good solution. Hard to sell these things, by the way, to young students, but I think they're important life lessons that we need to get across. Sorry, John, I am perhaps going a little bit late, but I've got just another 2 or 3 slides now, and this is by far the most dense. The others are very short. So when we're thinking about this interdisciplinary curriculum, as I mentioned, we want to give it some structure, but the real structure I want to give it is a network, and that's what the slides after this will be about. However, we are constantly drawn back to the sort of foundations of things. How do we ground the curriculum we want to give? And there are three aspects here I want to touch on. They're all fascinating, actually, but I think in this presentation, just a brief introduction will suffice. One is the idea that we do need some enabling disciplines to underpin everything we're doing. And Alan Wilson, the great mathematical geographer and modeler, thinks that these three, mathematics, computer science, and philosophy, are the most important disciplines to teach all students, and they can go from there. I actually don't agree with this, because I think it's really hard to say that you should start anywhere in particular, and that's what I'll come back to when I talk about the network as a curriculum on my last, curriculum as a network on my last slide. But Alan's take, I guess, is that with enough mathematics and computer science, you can cover pretty much all the sciences these days and engineering. And if you have a really good understanding of philosophy, then you can go deeper into the humanities and social sciences. Threshold concepts we've already touched upon. I think there are big challenges with threshold concepts. I'm excited by this idea of really trying to use them. But the literature shows many challenges. One is, what is the most relevant threshold concept? As I explained, we've got the problem statement as something we can fix on. So we've got 2 constraints, if you like. What lets us get into the discipline in a very short, intense period, but what also helps us focus on the problem statement. But a lot of the literature I've seen shows that people, get to 40, 50, 60 threshold concepts. By then, students are thinking, this is kind of not working. Why don't we just learn in the normal way? Why do we keep adding threshold concepts to it? So that's difficult. And related to that is a faculty consensus on what is a threshold concept for a discipline. I think we're getting around that well at AS in a way by allowing faculty to represent themselves and their disciplinary training by choosing the relevant threshold concept. But it's certainly, some faculty don't want to claim that they speak for the discipline, and therefore they don't want to say, you know, I think this is the most important 10 concept, because other people might disagree. I'm not sure that's, you know, entirely justified. There are, you know, we all have disciplinary training, so we can't just deny that. But I can see that people don't want to kind of represent their discipline the way they think isn't correct. And the last idea, also due to Alan Wilson, is this idea of super concept, which, if you like, are kind of almost the brother, or Cain and Abel, if you like, or the doppelganger of the threshold concept. So rather than being a gateway to a discipline, so a super concept, excuse me, is a big concept, deliberately and creatively spans several disciplines and areas of thought. So a beautiful one might be entropy, for example, which clearly grew up in physics and engineering in the 18th and 19th centuries, and then had that amazing kind of corroboration through information theory in the 20th century, but now can be used, as Alan Wilson himself did, in modeling traffic flows, human flows, all sorts of areas where you can pan out far enough to model people and animate objects as flows of gases. And of course, even entropy in the sort of information sense can even be applied to the arts now, to music and so on. So super concepts is this wonderful idea, I think, if you think of it as a kind of part of the intellectual history of ideas, that there are these big ideas, evolution might be another one, that grow up because they're focused on some quite narrow disciplinary area, but then have such conceptual power that you can apply them very creatively and productively, and giving predictive power in areas where it was never imagined they would originally be productive. And I've had the experience of teaching these to first-year undergraduates with great success. Of course, at first, their minds are blown, and they think, what am I doing here? But actually, when you ask them to apply things to their area of interest, and they delve into the research and the literature, they see this is tremendously creative and generative. So those are three kind of big areas we could use to underpin parts of our curriculum. We're using the threshold concepts. We'll also get some super concepts in year 2, and we'll try to move away, I think, from the idea of enabling disciplines, for reasons I'll say as we head towards the end of the book. So I want to mention emergence, because I've got my order of presentation in my own head a little bit. I keep, as we say in comedy, telegraphing the punchline here, because I'm talking about networks of education. That's where I'm going in 2 slides. And that's my big idea, the curriculum as a network. But of course, what's really exciting about a network, one of the things, is that you have this property of emergence. You can't quite predict from many complex systems that can be modeled as networks the kind of properties that will emerge from that system. So again, my nerves about speaking to engineers kick in a little bit, because I'm sure there are many people on this call who understand emergence from a technical point of view much better than I do, because engineers are already doing this. And here's a photo of Jessica Flack and Melanie Mitchell from the Santa Fe Institute, who recently have been writing and speaking about this. But there is this very profoundly important property of the modern world we're beginning to understand, that there's an element of unpredictability, inherent unpredictability and uncertainty in many of these complex systems. And of course, we had this whole trajectory through chaos theory and understanding in the late thousands and so on, but we're really grappling more, I think, with this idea of emergence now, and how we should set up so much of our structures, infrastructures, both social and physical, in order to recognize this. And for me, this is very important for education, because I think the idea of a learning outcome at some level is almost the opposite of emergence. It's saying that everyone has to hit these points, and then we've achieved it, we tick that box and it's gone to bed. It doesn't allow the possibility for emergent outcomes from the curriculum to be very divergent, to use another similar but not directly related word. Maybe the best result for a curriculum is that all the students emerge with different outcomes from their education. But we really struggle, I think, to assess that, and we struggle to know how to set up curricula that work like that. But if you think of the curriculum as a network, that allows that, because there should be an emergent property of a network which is different for every student, depending on how they put their network of ideas together. But I think partly there's an intuition that this is going on anyway, and that has, I think, driven this move towards assessing process rather than concrete outcomes. So in engineering, you of course assess process a lot, I know, but also artists do it by journaling and logging the creative process. Healthcare uses also assessing process rather than output, sustainability studies and so on. And I think this is great. I think this is really important. I think there's still a job to do to get the message over to many bureaucrats and other stakeholders, but I think we want to move towards assessing process rather than outcomes because it allows for better emergent properties. So I think, just to summarize in the last two slides, we're heading to this, we are in this space already, as I said, where we've got two massive drivers of interdisciplinarity from the complex world problem, the learning that's going on, and the fact that all this is happening in this explosion of the combinatorial space of ideas. So we can start to think of knowledge as a network of objects, if you like, a fact of knowledge, of expertise, and how these things are connected. That isn't trivial because it's not the same really as a transport network where the entities are very clearly defined as are the edges, the elements and the edges. But I still think we can do a lot of headway, make a lot of headway here and do much better than we are doing. And I think three benefits of this is that we will move towards a better understanding of what the emergent properties of that knowledge network in the student's own mind, if you like, in their own understanding of their own studies and their own expertise. Back to Lena, my student at the beginning, they're able to articulate then better their own learning and their own interdisciplinary expertise, and therefore I think their value in the world. And I do passionately defend many of these younger interdisciplinary experts because I think they're the most interesting people out there. They're the people going to help us solve the problems, but they don't have natural homes, if you like. But with a kind of network conception of their own learning and this understanding that it's emergent and therefore different to some other networks, I think we get more of that. Also, this type of curriculum as a network maps better onto real life after studies. You know, the world of work just simply does not map onto academic disciplines now, even in engineering. I know you're seeing this more and more, the idea of modular engineers that pick things from different areas. So the curriculum should be a better map to what the life students are going to live afterwards. And I think this last point is really interesting, that perhaps this idea of curriculum as a network moves us away from the ideas that we need some kind of foundational knowledge. You know, if you want to study identity, as someone was explaining to me recently, what is the first thing you study? Or maybe that's just the wrong question. Maybe what you want is that network of concepts and methods and connections between them, the synthesis again. And you need to be able to articulate that synthesis, perhaps even visualize it, but you don't need to think about a foundation. You can come into identity from psychology, then you might need some experimental science, or you could come in from anthropology or political science. What matters is making the connections between those things and then having a coherent network of knowledge which you can articulate and then has these emergent outcomes, which basically are a holistic understanding of identity, better than you would get from any individual. This is very beta, guys, engineers will understand. So we've just done this little thing on just parts of our curriculum. We haven't even filled it in. And it's too ambitious, actually, because it's too big. You should probably snip it there. But it's how a student might build up their own curriculum as network and start to think about how they conceive of the connections between things that they know. And I think we might live to see a day where you just put that on LinkedIn. And anyone interested will say, gosh, this person does photography and videography, and they've connected it to archive research and systems thinking. And if I go in a little bit more, we could put things in the other blobs and say, I did this by going to this library and looking at this, and I created this systems thinking diagram that looks like that. And you can see, I hope you can see from that, a more network conception of expertise, which is kind of more relevant to the modern world and reflects this interdisciplinary era we're living in. So that's it from me, John. I've been talking blind for a long time. I hope people have been able to hear and got something from this. Forgive me if it was difficult in any way. I don't know if the connection's even still there now, but I think I'll stop, John, and back to you.
Thank you very much, Carl. I think Babby was going to lead some questions. We'll take about 5-10 minutes and then we'll take a break and come back with the next session.
So if I can kick it off with a quick question. Carl, listening to you was a wake-up call. Yeah, lots of interesting ideas, lots of interesting approaches, and I'm going to follow up with you. So thank you. So here's my question. So I was the founding dean of engineering of a private university in India, BML Munjal University, which we launched in fall of 2014. So, you know, setting up a startup is a fascinating process. But one of the things we had to do, even before we admitted students, was start to make connections with industry. So my question is, how has your new school mapped to what employers want? and there's already Virgin, McKinsey, Metropolitan Police. So how has that process worked out?
Yeah, so there's a couple of answers. I'll try to be brief. We have very good contacts because one of our founders is a tech entrepreneur. We have also a tech entrepreneur. We have a lot of ex-McKinsey on the management team. Very, very good contacts. So the sort of very high level vague answer is they're very plugged into what's going on. The slightly lower level answer is, breadth of skills and competences is very highly valued now. They want people who are technically literate and certainly have done a bit of coding and able to upskill quickly, handle all the basics in Excel, but they also want people who can read and write and communicate. So that's the next level answer. And I guess the level under that is then we look a little bit more at the detail of our curriculum. How much coding do we need? What kind of employers do we match those guys to on their internships? But so that kind of stacks up. I think it works. But the high level answer is really important to me because in this country, and I think it's similar in the US, because I had some data recently from Burning Glass Technologies, that are a big data job analyst organization who look at billions of job postings. And they noticed the rise of this word hybrid in what employers are looking for, hybrid this, hybrid that. And there just is, again, because of this connectivity and crashing of old boundaries, a call for more and more hybrid graduates. So the difficulty in articulating this, Bobby, is that there are millions of individual stories, and then there's a very high level answer. And the kind of meso level answer is harder to make now because when banks are also gaming companies, and gaming companies are also, psychological welfare companies, where are these boundaries in the modern world? There's so many organizations will take so many different types of people and require so many different types of hybrid requirements. It comes back to this categorization again. So, we just talk a lot to employers. We have a burgeoning and very interesting professional development arm, which actually looks at some of these problem statements from various angles that we think are of interest to employers. And we sense that they're interested, and there's been tremendous buy-in so far.
Thank you, Carl. I see a question from Christine Kennedy, Iron Range, in the chat session. Could you explain in more detail the difference between problem solving and problem tackling?
I really should hand over to Annette for something like this, but okay. I think problem solving has a definite solution. So oversharing with you, if you like. I think one of the real challenges of, if you like, deep interdisciplinarity is when to stop. Thinking, ooh, another perspective would be really interesting here. Another way to see this problem would enrich my understanding, and then knowing when to act. And I don't think anyone has an answer to that, but I think anyone involved in this space has to be aware of it, because the more sort of conceptual thing about having different perspectives can always want you to take more time. And I think you just do have to act if you're going to do anything worthwhile in the world. So it's somewhere on that continuum, I think, where the acting requires you to say what you're going to achieve and then check whether you've achieved it. And that, if you like, is problem solving, or at least an attempt at problem solving. And problem tackling is like a little bit more like understanding what is going on here. What kind of recommendations could I make to people to do it? What kind of interventions could I make to stop people making terrible mistakes, if you like? And as I say, we've sort of not committed to problem solving because we think that's too ambitious for very young students to say that. But we don't want to just be, if you like, the problem tackling. We have to be somewhere on that continuum, which is honest about the richness and depth of understanding we're aiming to give our students. So that's what I see as more as tackling, understanding the problem deeply. But we will, to slightly contradict what I said earlier, we'll also have to have a narrative about how we're contributing this positively, right? It's not just got to be talk, it's got to be an output, a suggested policy, a suggested campaign, a suggested piece of code, whatever it might be. So that's the distinction really is between sort of the clear kind of KPIs almost, if you like, of problem solving, and the tackling, which is more like a kind of deeper understanding and an enriching of your understanding.
I can see that John is showing me the time on the back of his wall, so I'm mindful of that. We'll take one more question. This is from Annette Colmos Alberg. Carl, most people have been educated and have gained a disciplinary academic discipline. What would be your advice for disciplinary experts to collaborate? Where should they start?
So this is about inviting people in with a disciplinary background. Is that right, Annette?
And you have minus 2
Yes.
minutes to respond to that.
It is because you have your expertise, you have your identity. It's for us who have already been into education.
I mean, the easy answer for me is we recruited very well on that front. We recruited people with typically 3 degrees from 3 different domains: humanities, social sciences, and hard sciences or engineering. So that was great. I think there's just no substitute for finding the right people in your institution. At UCL, I've mentioned it, I was blessed having the engineers who got this, and you'll know many colleagues who particularly maybe didn't like the arts and sciences degree, but we also had brilliant neurosciences. We had the best physical chemist at UCL, loved what we do. And there's just no substitute for finding the right people. If they don't get it because they're so disciplined, you know, it's just not worth the effort of trying to sort of crack their minds open. You'll find someone else who will be able to do it. That's the only answer I can give at the moment. I'll learn more about the kind of cracking the mind open later on.
Great call. Thank you very much. You'll have an opportunity, everybody else, through the next few days to interact with Carl again. So let me hand this back to John 1 minute before deadline.